we're now going to be looking at our inverse chapter as part of our unit on transformations. Now there is some stuff up here that we're going to ignore for the moment because that will help with example 4. So we're going to, when we do example 4, we'll come back and we'll do those. But an inverse function, essentially, if you are curious to know, if you have a function that we usually write f of x equals x plus 7, and the idea is if you choose a number here, the function will just add 7. That's the whole point. Well, the inverse function would be one that undoes that. And so you would say the inverse function, and you would write f to the negative 1 of x, is one that undoes what the original function did. And so that's what an inverse function is. It's like backwards. It undoes something. To find it, we don't need to know that right now. You'll see that in example 4. But it is helpful here. To find it, we end up swapping the x and the y. So the inverse of f of x is denoted as f to the negative 1 of x. Sometimes we write it as x equals f of y, and we do that so that you can put an emphasis on the fact that the x and y are switching. Drawing the inverses is as easy as trading the x and the y. So that's all we want to do here is we want to graph these. So the first thing we need to do is just write down our 4 points. Now for absolute values, if we have already done that, the absolute values you had to the very first step was that you needed to flip all these ones up to write your points. And in this case, we're not going to do that. We're going to do something completely different. So we're going to write down our 4 points here. And we're going to take these points and we're simply going to be swapping the x and y location here. So this now becomes 3 comma negative 4. I just flipped them. This becomes negative 3, then negative 2. This becomes negative 2, then positive 2. And this becomes negative 3 and positive 4. So I can go now graph these, and I want to graph them in the exact order and connect the dots because I don't want this to look weird. So there's 3 and negative 4, and then negative 3 and negative 2. So I'm going to connect those. And then negative 2 and positive 2. Connect those. And then negative 3, 1, 2, 3, and 4. Connect this. So this drawing is the inverse. It will undo what the other drawing did. Now it does say here that it's as easy as trading the x and y, done. And it's also written as a reflection over the line y equals x. Now y equals x is actually supposed to be one of the easiest lines to graph because in terms of y equals mx plus b, the number in front of here is just 1. So your slope is 1 over 1. There's no number there. It has to be a 1. And then you're adding nothing. So you start at 0 and you have a slope of up 1 over 1, up 1 over 1. So you're going to get this diagonal line that's in like the very middle here. And what you should hopefully see is that this thing is flipped over this line. And so you get a reflection around this green one, or this yellow one gets reflected around the line and lands up back in this spot. So you don't need to know that for what we're doing here because I didn't do that when I graphed this. All I did was write down the 4 points and then swap the x and y. But that is something to keep in the back of your mind, that inverses are reflections around the y over x, because we're taking the x and we're reflecting it to the y, and we're taking the y and we're reflecting it to the x. So that's why this all ends up working. But I'm going to erase that because I don't necessarily need that. Great, now I just erased all my points. So let's just do another one here. It's very straightforward. You start by writing your points. So write down your 4 points. And then we can take these points and we can swap the x and y. So first write the negative 2, then the 4. Negative 3, then the 2. 3, then the negative 1. And negative 1, then the negative 4. So those are our inverted points, the points where we've swapped the x and the y. So now I can write those. Make sure you start at the top and work your way down, or start at the bottom and work your way up, and connect those dots. This connects to this, connects to this, connects to this. Otherwise your drawing could look really odd. Now -2 and 4, and then -3 and 2, and those are connected, and then 3 and -1, so down here, and then -1 and -4, right there. And hopefully you can see that it's symmetrical around this diagonal line that goes through the origin. So that's kind of what you're hoping for, that it looks symmetrical and reflected around that line, which to me it does. Now, you can take these, I'll zoom out in case you need to copy anything down. You don't need to write this because that's not as important as being able to draw this, though it is helpful to double check things. Now what we're going to do, in the next video, is we're going to take these and we're now going to transform them. So we're going to find out what the inverse is, and then we can shift it and stretch it and flip it and do all those sort of things to it. So that will be in the next video.